Dear my schoolers, this is my school channel and my name is Abiola. For this video lesson, you'll be joining me to solve the concepts of the topic algebra, right? We are going to be looking at several aspects, like the operations in algebra. You are going to look at the rules that follows the usage or the aspects of algebra. As well, we are going to consider properties of the Boolean algebra. As well, we are going to look at the difference between an algebraic expression and an equation, as well as linear inequalities. So a lot of things are well loaded in this particular concept. So do not go anywhere. Stay with me and I will be right back. You're welcome back to my school YouTube channel. Right there in this video lesson, we are going to dig through the topic algebra. Alright, so we have two basic aspects right here. So we have the algebraic expression and algebraic equations. Alright, so what is algebra? You are looking at that aspect of mathematics, or that part of mathematics whereby you are using certain kinds of letters or numbers to represent variables or quantities to represent quantities. That is correctly put. So those letters or symbols can actually represent quantity in terms of numerical value. All right, where A stands for 1, or A equals to 1, or B equals to 3. You can see such kind of concepts. All right, so for an algebra, it can actually express itself in the form of an equation or in formulas, or different ways as well. So let's come to algebraic expression. So when can we say an algebra has become algebraic expression? All right, so look at this. For instance, we have 3x plus 1. All right, so this x right here, I'm also talking about the components so that I can explain an algebraic expression. So I'm using this to relate this. So look at the components of this algebraic expression, right? So we have the letter, we have the sign, which we refer to as the operator. All right, then we have the constant, then we have the coefficient. So for an expression to be referred to as an algebraic expression, right, you must have at least one variable, and this is the variable or the letter or the symbol representing quantities, right? So this is an algebraic. Even if I don't have this here, this is already good enough to be referred to as an algebraic expression. All right, so having this, okay, still makes sense. All right, so this is an algebraic expression. Do you see that now? So if we are asked what are the components of an algebraic expression, a typical one, all right, so I'm going to have the coefficient, right? I'm going to have the variable, which I can refer to as the pro-numeral. Okay, we see that as a pro-numeral. All right, then I have the operator. So this can be plus, this can be minus, it can be divide, it can be multiplication. Then I have the constants. Do we see that now? So this is the constants right here. So this makes so much sense. So the basic components of an algebraic expression. So we can see, if we are asked how many terms do we have here, we have just two terms. All right, this is a term. Okay, and see, so we have the variable and the constant being connected together, right, with a times, right? 3 times x will give us 3x. So since they are being put together, so right here in this expression we have just 2 terms. So if I had this, we have 3 terms. All right, so if I take away this, we have just a single term. Do we see that now? So let's come back to our expression. We have 3x plus 1. So those are the basic components of an algebraic expression. Let's proceed. So what are the operations involved in an algebraic expression? So like I mentioned earlier, we can have addition, we can have subtraction, all right? We can have division, and we can have multiplication. As well, we can have the square roots, right, in an algebraic setup, maybe something like this, 4x plus root 3, right? Of course, we can have the square as well. I can say 3x squared, right, plus 1. You can say the square root, all right? Although this makes for another kind of algebraic expression. I can have the exponential. Instead of me writing divide, exponential, okay, this is an exponent. Then we can have the rational. Instead of writing out something like 3x divided by 1, okay, in algebra it is properly put as 3x over 1. Let me say this is 2 so that we can 3x over 2. Okay, this is the proper representation of this in an algebraic expression. So do we see all of those metrics? All right, so this works very fine. So these are the basic operations that we can find or relate with in algebraic expression. So what are some rules, okay, when it comes to carrying out our operations in algebraic expression? All right, so at first, when you are looking at something like this, is 0x, you don't need to even write out this particular term, all right, because it's going to come out as what? 0. So it's just negated, or it's not even represented at all. So for this is well done. So what if I now have something like this? 1x. So in algebra, we don't write 1x. What do we write? We write x. Do we see that now? Okay, so in algebra, if you are going to have, notice it's definitely plus 1x, right? Okay, let me change this number to 2. So in algebra, you don't need to write, since it's a positive and it's starting off the expression, so I don't need to write plus 2x. What would I just write? Just write 2x. However, if I have a minus sign, I can put it this way as minus 2x. Do we see that now? So these are just some of the rules that we can find or we should operate with in algebraic expression. All right, there's so much more as we go further and solve examples they are going to come out. Also in algebra, we have something we refer to as like terms. All right, so I can say this is a term, this is a term, this is a term, this is a term, isn't it? So like term means that expressions put together or such kind of representation, they have the same exponents and the same letter. What do I mean? Look at something like this. So if I'm asked to collect like terms, so imagine I have something like this, 3x, right, plus 4x squared minus 3y plus 2x squared. So what are the like terms here? You can see this, right? They are variables, right? This is also a variable. But you can see this is variable, letter x, this is letter y. So they are unlike. All right. So at first, so let's now move further. So we have x, x, x. You can see. So even though they are like variables, their exponents differ. Do we see that now? So the exponent here is 2, the power or the index here is 2. It is 2 here, it is 1. So this is unlike this, right? This is unlike this. Okay, so do we see that now? So what are the like terms here? The like terms, they have to have, number one, the same letter, all right, and the same exponent or power or index. So this is x squared, this is x squared. Then we can carry out our operation. So we can say 4x plus 2x squared. Do we see that now? So if this does not have the square, so it's going to be this and this that are alike. So we can refer to this and this as like terms. So very easy, right? So what are the types of algebraic expressions? So we have various types of algebraic expressions. So we have the monomial, we have the binomial, all right? So we have the monomial. So in monomial, you just have a single term in that expression. So like for instance, I can have just 3x, or I can have 4y squared. Do you see that now? Or I can have just something like this. I can have m raised to power 4. We see that now. So just a single term. So to now make this into a binomial, so we are looking at what? Just two terms, okay? Maybe like something like this is a binomial, this is a term, this is a term. This is a very good example of binomial, as well as this, okay? A very good example of binomial. Or I can have just something like this. Or the first one I use, which is I think 3x plus 1. That is a binomial, two terms, all right? So we can have a trinomial. So definitely you can tell me what that is, right? 3 terms. So I can have 3x, right, plus 4y plus 1. 3 terms. So once it's more than 3 terms, what you are going to have is polynomial. All right. So in polynomial, you have more than 3 terms. So you can have 4 terms, you can have 5, you can have 6, and the likes. All right. So those are the types of algebraic expression. So I take it further to the formula, right, involved in algebraic expression. You know, this is just like relating with the concept of differences of 2 squares. All right, like for instance, if I have something like this, a squared minus b squared, how do you work around this, right? If I ask you what kind of what type of algebraic expression is this, right? This is definitely a binomial expression. Do you see? We have 2 terms. Okay, and are they like? No, they are unlike terms because the letter differs even though the exponents are the same. Okay, so this will now be a plus b, right? So this is an example of the formula that we use in algebraic expression. All right, so let's still move ahead. So we are coming to the solution. So what are the solutions that we can profile, the solutions that we can implement regarding algebraic expression? So at first, you can look at expansion of brackets. You know, you can come to probably if you want to provide solutions to a particular kind of, so like let me say for instance I have 4x, right, plus let's say plus 4x squared, let's say plus let me say 16, all right, okay, let me make it another value entirely. So let me say 4x squared, let me say plus okay, let's say plus 9. Okay, so like this now, I can actually factorize because some of the solutions we can prefer to an algebraic expression can be expansion, it can be factorization, right? It can be simplification, and some like that. All right, so let me say I want to factorize this. That is, I want to collect common factor. So you know this is actually 4, right? And this is 9. You can see that now. So if I'm asked to just factorize just this alone, all right? So this now, you know, it can just be something like this. It can be 2, isn't it, x into bracket 2x, because 2 times 2, 4, x times x, x squared, so I have 4x squared. All right, so if I'm asked to factorize a kind of binomial algebraic expression, so let me say I'm making this, let me say 36. So the solution to this particular expression now is going to be, you know, 4 is common, so I have 4 into brackets, isn't it? Then I have x plus 9, x squared plus 9, because 4 times x squared, I have 4x squared. 4 times 9, I have 36. Do we see that now? So for the solutions that we can use for an algebraic expression, it may involve simplification, it may involve factorization, just like this. It can involve expansion, just like this. All right, and also substitution. So like for instance now, I can say substitute the value of x, right? So let's say where x equals 3, all right? So that means it will be 4 into brackets, 3 squared, you know, 36. All right, so remember your board mass, your order, then your exponent and the like. So I have 3 raised to power 2, that is 9. 9 times 4, that is 36. So 36 plus this 36, that is actually 72. So you can see that now. So if you are asked, what are the solutions that we can present or point to coming around algebraic expression? You know, you can refer to expansion of brackets like this, or you can come back to factorization or simplification or substitution like this. All right, so I believe this has been very helpful so far. So let's look at some properties of algebraic expression or properties of Boolean algebraic expression. All right, so Boolean algebra. Okay, so in such cases, when you hear the word Boolean, okay, or Boolean, so for this Boolean, you know, you are just looking at the concept whereby you can attach either a true or a false value to it. All right, so what are some properties that we can consider? At first, we can look at the property that we refer to as the reflexive. All right, so for the reflexive, you know, you are looking at a concept whereby A equals to A, right? The value of A is always A, right? Or the value of B is always B. All right, so we have the symmetric property. So for the symmetric property, you know, if A equals B, then you can also say that B equals A, isn't it? Then we have the substitution property. So for the substitution property, since A equals B, that means in any equation or formula or expression, you can actually use B to replace A. All right, just like the solution we profiled earlier, right? We said x equals 3. So anywhere we see x, what can we replace x with? That is 3. Do we see that now? So it can be substitution, it can be commutative, you know, it can be transitive, and it can be, you can have the identity property as well. Okay, so we are going to come to all of that as we move further in this video lesson. So let's come to linear inequalities. You know, one of the things that distinguishes inequality is the fact that you will notice the inequality sign, all right, which is this, or this, or this, or this, right? Basically this, all right? So linear means that the exponent, right, does not have a square. So if I want to write out a kind of linear inequality or expression, so I can have something like, let me say 3x plus 2, okay, is less than, plus 2, let me say it's less than 5. Do we see that now? Okay, so this is for linear inequality. So if you are now asked, what's the difference between an algebraic expression and an algebraic equation? All right, so some basic differences include, you know, for algebraic equation, what I'm going to have, instead of having 3x, right, plus 2, I'm going to have an equals to sign. It can be equals to 0 or equals to 1. Or any other value at all. It can be equals to 15. So one of the things that you can use to distinguish equation from an expression is what? The equal to sign. All right. So for algebraic equation, you usually find this there. Okay. Another thing is the terminologies involved. You know, for algebraic expression, you know, you can simplify, you can expand, you can substitute, right? You can factorize. But when it comes to algebraic equation, you just have one basic term, and that is solve. So anytime you see solve regarding algebra, you are referring to an equation. All right, take note of this. An algebraic expression is a mathematical phrase. It's a phrase in mathematics. Okay, it's, you know, a phrase. You know, basically there's no action, call to action thing there. So, but for an algebraic equation, you're looking at a sentence because it's equal to something. Okay, do we say that now? All right, so those are the basic markers between expression and equation. So let's move ahead. So what are the types of algebraic equations? So let's look at some types of algebraic equations. So far, you can tell that an algebraic expression with an equal sign makes up an algebraic equation, isn't it? Okay, so let's see this. And to an algebraic equation, you can notice that there's a left side and there's a right hand side, right? So like for the equation I think I used, so this is the right hand side, isn't it? This is an algebraic expression. This is an algebraic expression. This is the left hand side, and this is the what? Right hand side. Do we see that now? Okay, so this is making a lot of sense. All right, so coming to an algebraic equation, what are the types? All right, so we have the linear kind of equation. All right, so for linear, that means the ix exponent is actually 1. Okay, 3x plus 1. So we can see that the power here is 1. All right, so for quadratic, we are going to have 2. Okay, if it is cubic, we are going to have 3. Do we see that now? Okay, so we have so much more just like that as well. Okay, that's for so we've moved from linear to quadratic then to cubic. All right, so let's move ahead. What other types? Okay, let me just write it out. So I've mentioned linear, then let's start from somewhere more special. So we have the linear, which I've identified, right, for something like this, 3x, right? Then we have the quadratic, which is something like this. Let me say 4p squared, right? The index is 2. Then we have the cubic, which is actually something like this. Let me say 2m raised to power 3. Do we see that now? Okay, then we have the literal algebraic equation. So for the literal, you know, basically you are looking at that kind of expression whereby you are pointing to change or subject of formula. Do you see that now? So change your subject of formula. So probably you are given a particular formula, you're asked to make so thing the subject of the formula. So you know all of those maneuver that we do together. All right, so that is it for literal. So we have literal algebraic type of equation, right? So we have so many as well. Okay, so what are the solutions that we can prefer to an algebraic equation? So all the methods, okay, that we use to prefer solutions to algebraic equation. So at first, we can actually use the factorization method, right? You can use the factorization method. You know, probably you have an expression like this, x squared minus x plus 3. You know, you want to factorize, whereby you have something like this. I have not solved this, all right? I'm just trying to make an instance from here. So this is the factorization method, all right? So I just put this up right now on the spot, okay? So then we have You can also use the graphical method, whereby you use your graph. All right, you can use the graphical method. So I want to give you some kind of hints when it comes to graphical method. All right, so take note of this. If the coefficient of x is positive, look at this, we have x squared, right, minus x plus 3. You can see the coefficient here is 1 and it's positive. Okay, let me just put a coefficient here. You can see it is positive. So whatever kind of graph you are going to get, the parabola will be like u. All right, so if this is negative, your kind of graph that should come out will look like n. So positive, negative. Take note of that. All right, so if it is a linear kind of graph, it will just be a straight line. But once it's quadratic, you should be expecting something like this on your Cartesian graph. Okay, Cartesian basically is talking about the x and the y-axis. This is y-axis, this is the x-axis. This is positive y, this is the negative y, this is the negative x, this is the positive x. So this is a typical Cartesian graph. All right, so we have the graphical method. We have completing the square method. Right, completing the square. Then we can also use the quadratic formula, which we refer to as, okay, the almighty formula. All right, so we refer to it here as a quadratic formula. Okay, so quadratic formula. So far I've listed 4. As we proceed in this video, more content will be reviewed. All you just need to do is to click on the link on the description below. This is going to get you to the My School website. Right there you get to have access for your subscription, right, to the video lessons where the full content is well prepared and explained. So do not forget to hit the like button, also click on the subscribe button, and always tap on bell notification for you to get alert immediately we upload the next video lesson just for you.